All right. So now that we've recapped linear equations and quadratic equations, we can talk about the 4 types of equations that we're going to get into today. Okay. So how do I want to approach this? From last time, we looked at rational expressions. So this third type of equation is called a rational equation. This is not a polynomial equation. Because there are variables in the denominator of our fractions. And we went over the definition of polynomials a few weeks back. And we said that, okay, if you have a variable in the bottom of a fraction, that's not technically a polynomial. The form of these kinds of equations, they all look sort of different, but the key feature is that you will have maybe a number or an expression up here on top of the fraction, and then you'd have like x. Let me use some concrete values. So I'm going to say -5 on the bottom, plus maybe you have some other expression up here. Maybe you have a different polynomial in the denominator of this fraction, and then that's equal to maybe some number or some other expression here. So let me do this. I have no idea. Okay. So I'm trying to be very general with this because they're going to all look sort of different, but the main thing that identifies them, right, is that there is a variable expression or a polynomial expression in the denominator of one or more of the fractions. Okay. One other note about rational equations is that we're going to try to eliminate the fractions. But this will reveal either a linear equation or a quadratic equation. So then we either solve the linear equation or quadratic equation, and then we'll have our solution. The other note is that you must check for restricted values. And we'll talk more about that as we start solving rational equations. Okay. The fourth equation, we actually haven't done any kind of workup to this kind of an equation. We haven't done anything that builds up to it in some sense. But it turns out that these are closely related to quadratic equations. They're called quartic equations. And all this time I've been saying that quadratic, you need to think about the Spanish word for squared, which is cuadrado. And quartic actually does mean 4. So quartic equations take on this form. It is a x to the 4th power plus b x to the 2nd power plus c is equal to 0. So we would call this a quartic trinomial. And it turns out that when we get problems like this, that the one way that we can solve them, or the one way I'm going to teach you to solve them, is using the zero factor property. So it won't be too terrible. It'll be very similar to solving a quadratic equation. But these are 4th degree polynomials as indicated by the highest exponent here, which tells you that you're actually going to get 4 solutions. So that's going to be fun. Okay. There are 2 other kinds of equations that we're going to go over, but we'll cross that bridge when we get there. I want to jump into rational equations and quartic equations for today. Okay. And then we'll see, as we get farther along, if we have time to sort of explain and then work some problems on the other 2 types of equations. Okay. So let's go ahead and jump into this thing. Solving rational equations. I feel like when you're solving a rational equation, there's no point in me it's sort of like, I don't know if you ever hear somebody say like, don't talk about it, be about it. When it comes to rational equations, the only way we're going to learn is by just jumping into solving an equation. So let me throw one at you guys and I'll walk you through it. As we walk through it, please, please, please be sure to, voice any of your questions, comments, or concerns as usual, just so that if I do something that seems confusing or the logic doesn't make sense, we have an opportunity to have a discussion about it. Okay. So I'm going to write this equation down. It's 4x plus 3 over 4 minus 4x over x minus 4 is equal to x. Now, just to prepare you emotionally before we get into this, I know that you probably are feeling lots of trepidation right now. I want you to take a nice deep breath in and just let it all out, okay? We're going to do this. I'm going to walk you through it. It's going to be fine. Everything is fine. Okay. There's a lot of scratch work for this problem. So I'm going to use this column over here to try to confine all of my scratch work over here on the right-hand side. And I'm going to try to keep all of my actual work for the problem just going down in a linear fashion the way I normally do, right? But you want to keep your scratch work out to the side. So the first step in having an equation like this is to just breathe, because I know that it looks intimidating. There's a lot of terms here, or at least it looks like a lot of jumbled numbers and variables and fractions, and it's super scary. But really, you should just look at this and say, okay, I have 1 fractional term here, 2 fractional terms here, and then I have a whole number term over here, right? This fraction thing, don't try to simplify it. Don't try to make it like solving this individual thing. You can't simplify it, right? This is one thing, this is one thing, this is one thing. And just we're approaching the problem knowing that there are 3 terms. Okay, so each of these terms we have to inspect to see if they have a variable expression or a polynomial expression in the denominator. Because as we saw on Monday, we might have restricted values. That is, if we plug in a number for x, does it make the denominator 0? We can't divide by 0, so we need to basically watch out for that restricted value. So the first step is going to be find the restricted values. And there may be more than one restricted value, or they may just be one. But what you're looking out for is whichever term has a variable in the denominator of the fraction, only in the denominator. Okay, so this fraction does not have a variable, does not have an x in the denominator. So I don't have to watch out for this one. The second term does. We have this term or this expression in the denominator that could potentially be 0 for some choices of x. This term does not have a denominator. Well, really, it has a denominator of 1 if you wanted to think about it that way. So the only term that we have to watch out for is term number 2. Okay. So what value of x here, just by examining the denominator, would make the denominator 0?
4.
Yeah. 4. So remember, we had a process for finding restricted values, and that was if you set the denominator equal to 0 and solve that by adding 4 over to the other side, you would find that 4 cannot be our solution, because if it was a solution and we plugged it in, we would have something divided by 0, which would be impossible to solve. Okay, so the restricted value, RV, is going to be 4. So as we proceed to solve this thing, if we get a solution at the very end that is equal to 4, we have to throw it away. It can't possibly be a solution. Okay, is everybody on board with that? Or does anybody have any questions? All right, we'll have to keep that in mind. So I always write that somewhere on the page. Okay, so make sure that you don't lose that information, because that's going to be important. The next step is that we need to eliminate the fractions or cancel out the denominators. And the way we've eliminated fractions in the past is by multiplying each term by the least common denominator of all of the fractions. Well, so far, if we examine all the denominators, we have a 4, we have an x minus 4, and we have a 1. So the easiest way to find the LCD of a problem like this is just to multiply these things together. Now, I say multiply liberally. I mean that I'm just going to write them next to each other as though I'm preparing to multiply them. I'm not actually going to multiply or distribute this out. And notice that I did not include the 1 here. Does anybody know why I did not include the 1?
Because it won't change your answer?
Yeah, exactly. Because it won't change the value of the LCD. So we can sort of ignore anything that has a fraction with the denominator of 1. Okay? Does that make sense? So what I'm going to do is take this least common denominator. Again, I'm not going to multiply it out because we're going to try to multiply things but cancel factors. Okay, so I'm going to write my problem down again, but this time next to each term, I'm going to leave a little bit of space so that I can write the LCD. So I'm going to write 4x plus 3 over 4. And I'm going to leave a little bit of space in the front of that, minus 4x over x minus 4. And I'm going to leave a little bit of space on the right side of that. It doesn't matter whether you leave the space to the left of the term or to the right of the term, because remember, when you multiply, it doesn't matter what order you multiply those terms in. Okay, I'm going to put the x here. You don't have to put this as x over 1. You could just leave it as x. But we want to multiply in the LCD. So I'm going to put 4 times x minus 4 right there next to the first term. I'm going to put a little dot here, 4 times x minus 4 next to the second term. And I'm going to put 4 times x minus 4 next to the third term. So again, if you counted the number of terms in the equation, that's how many times you're going to rewrite the LCD as you multiply it into the equation. Okay. So now we're going to take this one term at a time to start to simplify the expressions. So I'm going to ignore these guys over here and just focus on these terms that I'm multiplying out. Keep in mind that when you multiply something that you're also dividing by, that those will cancel out, right? So if I'm multiplying by a 4 and then dividing by a 4 later, those 4s will cancel out. But just the 4s, not the x minus 4, okay? So this 4 will be canceled out with this 4. So what is left over is just going to be the x minus 4 that I multiplied in, and then this 4x plus 3 that also didn't get canceled out. So I'm going to put that in parentheses because we're going to have to multiply those polynomials in the next step, right? But at this point, I would just say cancel out what you can cancel, and then just write these two terms down, okay? Or the two polynomials down. Then we can go to the middle term. Okay. So once you have that down, focus your vision on the second term. I'm going to bring the minus sign down. And can anybody tell me what's going to cancel here?
X minus 4.
The x minus 4, right? So I have this polynomial factor here that I'm dividing by, but I'm also multiplying it over here so I can cancel those factors, which means I will have negative 4x times 4 left over. Okay, now we're going to focus on the last term. The last term looks like we're multiplying 1, 2, 3 things together. So what I would do is just multiply the first two terms together and just call this x times 4 is 4x times x minus 4. So I'm just going to put x minus 4 in parentheses and leave it alone. I know it seems a little like strange or pointless to rearrange that just by flipping the order of the 4 and the x. But I guarantee you that this helps a lot of students prevent themselves from making mistakes, okay? So now we can look at what we have on this line. We're still going to look at one term at a time and multiply out what we have left over. So when you look at this first term or first set of terms, we're multiplying this factor times that factor. So we have to distribute that out using the handshake method that we learned before. Or maybe you might remember it as foiling. So we'll have to multiply x times x, or x times 4x, and then x times 3. And then we'll have to multiply -4 times 4x and -4 times 3. This is going to result in 4 terms. So it's going to be a lot of writing, okay? But just slowly go through that. Do not rush. X times 4x is 4x squared. Then we should have x times 3, which is plus 3x. -4 times 4. Remember, you're multiplying, so that'll be -16x. And then -4 times 3. Again, remember, you're multiplying, so it's -4 times 3 would be -12. So all of this came from multiplying out the first two terms. Then we're going to multiply out the next two terms, which you could just interpret as -4x times 4, which will just be -8x. And then finally, we have our equal sign. And, you know, there's a reason why I told you to rearrange this so that you write it as 4x, because it's going to be easier to multiply this as a 4x times each of these terms. So that'll be 4x squared minus 16x.
In the middle, aren't you multiplying? So wouldn't it be -16x?
Oh yeah, you're totally right. I did the mistake, the very common mistake that I guarantee some of you will also do, right? So in my head, I told myself multiply, but I then added for some reason. But this should be 16x. That is absolutely right. Thank you so much. So 4 times 4 is 16. -4 times 4 is -16. That would have really messed this up. Did anybody else see any other mistakes that I might have made? X times that is 4x squared. X times that is 3x. -4 and 4 is -16x. -4 and 3 is -12. -16x. 4x squared, -16x. Looks good to me. Okay. So let's see. We found the restricted value for some reason. We're holding that hostage for later. We eliminated the fraction by looking at the problem, finding the LCD, basically taking those denominators and multiplying it in by each term. That canceled out fractions. And then we just had a jumbled mess of terms that we ended up getting once we simplified the expression. And actually, we're not done simplifying. So really, that's what we're doing right now. We're simplifying the equation. So on the left-hand side, we have all these terms, but let's go ahead and simplify it by combining like terms because there's just a lot going on, right? So it looks like on the left-hand side, we have a 3x, a -16x, another -16x. So we would have 4x squared. I'm just going to bring that down. We're going to combine like terms here. So why not just grab the calculator so we don't make any mistakes? +3 minus 16 minus 16 gives you -29. So that's -29x. And then we'll just bring our -12 down. Is equal to 4x squared minus 16x. We have not done anything over here because there's nothing to combine. Okay. Does anybody have any questions up to this point? Okay. Well, now if you look at the equation, the highest variable or the highest exponent on the variable is 2. We have some x squared terms in here. So that sort of makes me think that this is going to be a quadratic equation. And usually with quadratic equations, we want to get all of our terms to one side of the equation and set it equal to 0 to see if we can get that in standard form. Okay, so let's try that out. Let's move all of our terms to one side of the equation. Well, if I did that, I might be able to say, okay, let me subtract 4x squared here, and let me add 16x here. I'm going to do that same thing to this side of the equation. So I'm going to subtract 4x squared here. I'm going to add 16x here. This side of the equation cancels out, but do not forget to put a 0 over here, because that's what we mean by canceling out, right? 4 minus 4 is 0. Negative 16 plus 16 is also 0. So 0 plus 0 is 0. Then it turns out that 4x squared minus 4x squared, that also cancels out. So that's a 0. Negative 29, negative 29 plus 16 gives us negative 13, negative 13x. And then we can just bring the negative 12 down. So at first, this thing looked like a quadratic equation. But what kind of equation is this really?
Linear equation.
Yeah. So now, for the fourth step, you're either going to solve a linear or a quadratic equation. Well, it turns out that this is a linear equation, so we'll be able to solve it pretty simply. We can move the 12 over to the other side, right? And call this positive 12. And that's equal to negative 13x. And then we could divide by negative 13 on both sides. So we would have x is equal to negative 12 over 13. That fraction cannot be reduced. So that's going to be our solution. The fifth step is going to be to check your solution against the restricted value. If this is not equal to the restricted value, then this is going to be a valid solution. And since our restricted value is 4, negative 12 over 13 is not 4. So this is going to be our solution set. You would put your solution set like negative 12 over 13. That's your solution set. So if they have you enter the solution as a solution set, you're just going to type in the number.
Sir,
Yeah.
I have a question about the homework. For the ones that you were just showing us, you know how to like drag it and like place it there. Is there like more than like one question in that one, or like do we have to put many of them in? Like I don't understand.
In just to go back to that particular homework, in that one question, there were 10 sub questions.
Oh, okay. I see
You
it.
had to
I see
do
it.
each of the 10 and then drag the solution to the corresponding box.
Oh, okay. Okay, I see it. I see it. Thank you.
Yeah. Okay. So that would be the end of this process, right? And it felt like there was a lot of steps. We walked through it really slowly. I did with excruciating detail. But whenever you guys start working through them, you'll start to pick up speed, but you want to start off very slow, walking through it the way I've walked you through it here. Okay. Did anybody have any questions as you look at all of this, right? It took up an entire page. Sometimes these problems will take up an entire page or more. So just be prepared for that. This is not a race, it's a marathon. And knowing that these problems take a lot of time, I will give you what I feel like is going to be an appropriate amount of time on the test, because I don't want you to be worrying about that clock counting down. I know these take a while. But did anybody have any questions at any point here? Or did the logic make sense as we were going through it?
It makes sense. It's just a lot to
Oh.
remember when you don't have like worked
Yeah.
out problems that kind of help you.
Yeah.
Exactly.
And that's why, like, on your sheet of notes that you can make going into the test, sort of what I expect you to do is not write out the worked example like this stuff over here, but these steps for solving rational equations. Like on my note sheet, I would write solving rational equations, step 1, step 2, step 3, step 4, step 5. You just have to remember what it means to find the restricted value, what it means to eliminate the fraction by multiplying by the LCD, right? Simplifying the equation, solving the linear or quadratic. But these steps should be able to guide you in the right direction. But again, like I totally acknowledge that it's going to take a lot of practice, which is why we're going to do another problem like this. Did anybody have any questions about this one in particular, though? All right, let's do another similar one. Okay, we're going to solve 3x minus 1 all over 3 minus 2x over x minus 1 is equal to x. Okay, this time I'm going to go a little bit faster, but I will write out the steps here. First is that we're going to look for the restricted values. Two, we're going to find the LCD of all the terms. And I think that maybe I said in the last problem, use the LCD to eliminate the fractions. But really, we're eliminating the denominators of those fractions. Once you do that, you're going to have to simplify or clean up, because it's going to look like just a jumbled mess of symbols and terms. So simplify the expression. The fourth step, you'll ask yourself to solve the linear or the quadratic equation. And then finally, you need to check your solution against the restricted values, value or values. Okay. So let me know when you guys are ready to begin. Okay, so right off the bat, can anybody tell me what the restricted values for this problem are?
1.
Yep. Yeah, so x cannot be equal to 1. Can anybody tell me what the LCD of these terms is? Least common denominator.
3 parentheses x minus 1.
Yeah, 3 times x minus 1 in parentheses. Good. Okay. So then I'm going to rewrite the problem, but I'm going to give myself space to go ahead and multiply the LCD by every term. We have x there. Okay. The LCD, I put in pink here, so I'm going to keep that color consistent here. I'm going to multiply this by 3 times x minus 1. I'm going to multiply the second term by 3 times x minus 1, and then times 3 times x minus 1 there. Okay, so I'm assuming that maybe some of you guys are starting to catch on to this process. For the first term, what cancels out?
The 3.
The 3's. So I'm going to cross out my 3's, and I'm going to rewrite on the next line the 2 polynomials that are left over. So we have x minus 1 times 3x minus 1. For the second term, what cancels out?
X minus 1.
The x minus 1. So I'm going to cross those polynomials out, and I'm going to write down what's left over, which is negative 2x times 3. And then for the last term, because that wasn't a fraction, nothing is going to cancel out. So let me go ahead and just swap the order of this and call it 3x times x minus 1. Okay. Are you guys all on board with that? Or does anybody have any questions? Am I leaving anybody behind? Okay. Well, since we've eliminated the fractions, all we have to do is simplify the expression here. So it's going to be a lot of jumbled mess once we, get to the next line, but we're just going to have to jump in. Okay. When you multiply these polynomials out, you'll have 4 terms. So this stuff will be x times 3x, x times 1, negative 1 times 3x, negative 1 times negative 1. So we should be getting 3x squared minus x minus 3x positive 1. Okay. That should be from the first term. And I'm just putting the little line above it to indicate that that is where it's coming from. Those 4 terms come from multiplying those 2 polynomials. Was everybody able to FOIL that out and get the same set of terms? Okay. Then we're going to go ahead and multiply these 2 terms out. And we should get, we're multiplying, okay, just because I made that mistake last time. Negative 2 times 3 should be negative 6x. Okay. Is that correct, Brooks, or have I made a mistake again?
Perfect. It's
Okay.
perfect.
Yeah, good. For the terms on the other side of the equal sign, we're going to multiply this 3x into this polynomial. So we should get 3x squared minus 3x. Okay, does everybody have the same terms? And the multiplication seems right to you guys? Okay. Now we're going to combine terms on the left-hand side whatever like terms. So we have negative x, negative 3x, and negative 6x. So that'll be -1, that'll be -4, and then that'll be -10, negative 10x. And we'll just bring the 3x squared and the +1 down. And that's equal to 3x squared minus 3x, okay? It's starting to look like a quadratic equation, but we can't always be sure until we move all of these terms over to the left-hand side. So we're going to continue simplifying by subtracting this 3x squared by adding this 3x. So we're going to subtract 3x squared by adding this 3x here to get basically this is going to be the equation that we finally have to solve to get our solution. These cancel since they're opposite signs. This is going to be negative 7x plus 1 because that just comes down. And then these guys canceled to give us 0. So it turns out that this is just a linear equation. So now we just have to solve for x. Okay, so you might move the 1 over to the other side, call that a -1. Then divide both sides by -7. So you should get x is equal to 1 over 7. Our restricted value is that x cannot be equal to 1. But since this is not equal to 1, this is a valid solution. So our solution set is just 1 over 7. Still a lot of work, but that went a lot faster, right? Okay, let me give you another one, but this time I'm gonna sort of give you about 10 minutes to solve it on your own. Or before I do that, did anybody have any questions or get lost on this part or have any like comments or like, oh, that was kind of weird. Let me ask about that right now. Okay. Okay. Let's do this one. So we want to solve. This is going to be x over x minus 2 is equal to 2 over x minus 2 plus 2. Okay. And again, I'll write the steps over here, but I want you guys to try to solve it on your own. It's the exact same steps, okay? You're going to look for the restricted values. You're going to eliminate the fractions using the LCD. You're going to simplify the equation. You're going to solve whatever equation you get. And then you're going to check that against the restricted value. There we go.
Quick question. So to find my least common denominator, I'm going to take 2 minus x and walk it out with the 2 minus x.
With the x minus 2, but yeah.
I'm sorry, x minus 2.
Yeah.
And then I'm gonna take that answer and apply it to all the top denominator or to that term.
To each of the terms. Yeah. You got it.
Okay,
Yeah. And notice, that both of these fractions have the same denominator. So when you include x minus 2 in the LCD, you do not have to put it twice, right? And the reason why is because once we multiply x minus 2 by each of the terms, both of these x minus 2's will cancel. So you don't have to put x minus 2, x minus 2. You just have to put it once. Okay.
okay.
So now let me give you 10 minutes to solve this. And you guys talk it out with each other. I'm going to go grab some water really quick. Is anybody stuck or need some assistance? Is anybody done with this particular problem? We still working on it?
I'm thinking I'm done, but I'm not sure if I'm.
Okay.
I think I'm done too, but we'll see.
Okay, yeah. All right. I'm going to jump in and start working it. I'm going to narrate as I work on the problem. And if you're still working on it, just continue to ignore me and continue working on it, okay? So the first thing we have to do here is identify what the restricted value is. If you look at both of these terms, the denominator has x minus 2. So if we were to set those equal to 0 and solve them, it turns out that the restricted value for problems like these are pretty easy to see that x cannot be equal to positive 2. Okay. Similarly, we need to find the LCD. And since the only things that have fractions or denominators are these guys, and those denominators are the same, well then x minus 2, that polynomial, is going to be the LCD that we multiply through the entire equation. Okay, so those are the two pieces of information that we need before we begin to solve this problem. Okay, I'm going to go ahead and rewrite the problem because I know I'm going to have to multiply something in. Leave myself some space. 2 right there. Okay. And I like to use different colors, colored pens or highlighters when I'm working these problems, just so that I can visually differentiate one line from the next, or like what I've added to a particular equation or multiplied in. So I highly recommend that you're using at least 2 different colors to differentiate these kinds of problems, because it is a lot of writing. We're going to write x minus 2, multiply this polynomial by every term. And since we have 1, 2, 3 terms, we're going to write it in 3 times. So once right there, once right here, and then once right here. X minus 2 for this first term will cancel out, leaving you just with that x. So I'll bring the x down. X is equal to. X minus 2 is going to cancel out over here as well. So we're just going to bring this 2 down, plus 2 times this polynomial. Well, you have to distribute that in. So we should get 2x plus 4.
Would it be a -4?
Yeah, it would totally be a -4. So 2 times -4. Made that mistake. Boom. Good catch. Thank you. So now we're going to combine some like terms. Boom, boom. Those are like terms. So I'll have 2x, and then 2 minus 4 is going to be -2, is equal to x over here. And now all we want to do is isolate the x, since this is a linear equation. So I'm going to subtract 2x on both sides. These guys cancel out. This will be -x is equal to -2. And then if we divide both sides by -1, we can get rid of the negative sign. So this will just be x is equal to 2. Okay. But our last step says to check this against the restricted value. And at the very beginning of this problem, we said that the restriction for this equation is that x cannot be equal to 2. So that means that this solution here is not valid because it's restricted. So I need to throw away this solution. And what you would select in MyLabs Plus is a little bubble that says no solution. And at this point in the problem, or in this kind of problem, students will typically say, oh man, I did all that work for nothing, and I can't comfort you in this fact. It is true that you did all that work. I don't think that it was for nothing, but yes, for this particular rational equation, there is no solution. But that's the kind of situation that you'll run into sometimes. Some of these equations don't have a solution. And so that's why this last step is critically important for solving these kinds of equations. Okay, because if you type in the solution set is 2, but that has already been determined to be restricted, well, then you're not paying attention, right? And the details matter. So always check your proposed solution against the restricted value. And if you get this after all of that work, do not marry yourself to this solution. Throw it away, okay, if it's restricted. Does anybody have any questions about that particular problem?
Could you have up there where you're at the x equals 2x minus 2?
Yes.
What if I wanted to keep my x positive?
Oh, yeah. If
Could
you
I
wanted, yeah, you could subtract the x over here.
over here and add my 2 on the other side?
Yeah, because if you subtracted the x over here, you would have a positive x. And then if you added the 2 over there, you would get positive 2. So you would end up with 2 is equal to x, which is the same thing.
Okay.
So whichever way you want to play it, it doesn't matter which direction you're moving things into, as long as you're adding and subtracting correctly.
Okay.
Yeah. Any other questions? Okay. Well, I want to show you guys one more, because there's one more like step above this in terms of a complicated rational equation. So let me show you that particular example, and then we'll take a break. Okay, so let me see where I put it. That's a good one. We want to solve 3 over x minus 3 plus 7 over x plus 8 is equal to 5 over x squared plus 5x minus 24. And because this is a step up in our complicating an already complicated process, I'm going to walk you guys through this one. Okay. It's basically the same steps as our last several problems, right? Or at least it felt like several problems. I think it was only like 2 or 3. We're going to do the same things. We're going to start off with our restricted values. We're going to look for the LCD. But if we look at the denominators in this set of terms, you can find the restricted value from this one really easily. It's 3. The restricted value for the second term is -8. But then this thing is a quadratic trinomial in the denominator. And it's sort of hard to tell what could I plug in for x so that it cancels out to 0. But usually, if you look at this guy and this guy, these two factors are related to this quadratic polynomial. And what do I mean by that? Let's just complicate it a little bit more by saying step 0. If you have a quadratic or a trinomial here, we're going to factor the trinomial denominator. And I'm going to call it a trinomial. It could just be a quadratic, but in any case, we need to factor this thing. So we'll factor this using the AC method. And if it takes you a little bit of time to do the AC method, don't worry about following along. Just know that I'm going to use the AC method here. What I'll end up doing is looking at the factors of 24. That will add to give me 5. So that would be, what would that be? 8 and 3. 8 times 3 is 24. But I would need a negative somewhere. So I need this to be, let's call it a negative 3x and a positive 8x. Okay. When I factor out the first two terms, I'll have an x here, which will leave me with x minus 3. I factor out an 8 over here, so I will have an x minus 3 here as well. So my factors will be x minus 3 and x plus 8. Notice that these guys, these factors, so like if I wrote this in factored form, it would be these two factors, but these two factors also occur in these two terms over here. So what you could do, and I know this is a lot of rewriting, you don't necessarily have to do this, but I like to do it. We're going to rewrite the problem, but the last term, I'm going to rewrite it with the denominator in factored form. Okay. And having it in factored form is going to be really nice for us in one of the later steps because you'll be able to see that things will cancel out really easily. Okay. So it's just about visualizing that cancellation later on. What remains the same, though, is that we're going to go ahead and find the restricted values, which in this case we said x cannot be equal to positive 3 or negative 8. And the restricted values of this as well, if we set this equal to 0, and we went through that whole process of setting each of them equal to 0, we would still get these numbers. So there's no additional work that we have to do here to find some other restricted values, because the restricted values from these two terms are the same restricted values here. Right? Like if I plugged in positive 3 here, this would be 3 minus 3, which is 0, times something, which would still be 0. Similarly, if I plugged in negative 8 here, negative 8 plus 8 is 0. And then 0 times something is still 0. So those would still be our restricted values. There's no additional restricted values. So my restricted values are 3 and negative 8. And it turns out that the LCD, just like in the previous term or the previous problems, are just going to be these guys. So I'm going to write x minus 3 times x plus 8. I'm not actually going to multiply that out because it would just be more complicated than it needs to be. And since these guys occur as factors of this other denominator, I don't have to write them twice, right? I just have to include them once. And you'll see why in the next step, I don't have to double up this factor or double up that factor, okay? So this is the LCD. So the second step is to what? Eliminate the fractions with the LCD. So again, lots of writing. I'm going to rewrite this problem, but I'm going to give myself a lot of room to write the LCD in. So x minus 3 plus 7 over x plus 8. Give myself some space. 5 over x minus 3, x plus 8 there. Okay. And I'm going to try to squeeze in the LCD here, here, and here. So I have x minus 3 and x plus 8, x minus 3 and x plus 8, x minus 3 and x plus 8. And I'll let you guys catch up because I know that's a lot of writing. Okay. So we're going to take this one term at a time. Looking at the first set of terms, when I multiply the LCD here, what will cancel out?
X minus 3.
The x minus 3. So I'm going to cross those out. And what's left over, I'm going to swap the direction, the order of this just so that it feels a little bit more natural. I'm going to put 3 first times x plus 8. Okay. Remember, order doesn't matter here. I just think that when students see the distributive property, usually they put the number first. So that's the only reason why I've changed the order. Okay. So that's all that's left over, the 3 and the x plus 8. For the second term, what cancels out?
X plus 8,
The x plus 8. So what's left over?
7 times x minus 3.
Yep. And then for the last term, what cancels out?
X minus 3 and x plus 8.
Both polynomial factors cancel out, which will leave you with just 5. So it was a lot of ugly writing in all the steps before this. But once we canceled out those fractions, now we're left with something that's a lot simpler to work with, okay? So now we can distribute out and simplify this problem. So that would be step 3 is to simplify. So we should get 3x plus 24 here, plus 7x minus 21 there. And that's equal to 5. Check my multiplication on that, make sure that's correct, because clearly I've been known to make mistakes. And if there are no objections, then we can just go ahead on the left-hand side of this equation, combine our like terms. So we have 10x, and then that'll be 24 minus 21. 4 minus 1 is 3. So that should be positive 3 is equal to 5. Okay, so that's just a linear equation. So in this particular problem, we're just going to solve the linear equation. So you might subtract 3 on both sides, get a 2 over here, and then you might divide by 10 on both sides. So we get x is equal to 1 over 5 when you simplify the fraction. The last step is to check your solution and compare it against the restricted values. But since our restricted values are 3 and 8, so x cannot be 3 or -8, then this solution is good. So at least in this problem, we don't have that unsatisfying feeling where it's like, oh, you did all that work for nothing. We did all that work and we have a solution. So our solution set is just 1/5. Does anybody have any questions about that one? Okay. Well, in my head, compared to the last two problems that we solved, the thing that's complicated or a little bit more complicated about this one is that you have to factor this trinomial first. Write it in factored form, and that's just going to make it easier for the next step whenever you start canceling stuff, right? If you're trying to cancel things and this line right here, I don't know, 1, 2, 3, 4, like step 4 or line 4 is more complicated than you originally intended, or if you still have denominators, then you've probably made a mistake in selecting your least common denominator. Okay? Because once you multiply that in and things cancel out, you should have a single line with no fractions, and it's either going to be a linear or a quadratic equation. Okay. Well, let's take a break if there are no questions, and we'll come back at 1:55, and we're going to shift gears to a different kind of equation that we're going to learn how to solve. Okay. So let's take 10 minutes, stretch, get water, do what you got to do, and then we'll come back here at 1:55. Okay. So this is going to feel really familiar. It's going to feel just like solving quadratics, at least using the zero factor properties to solve quadratics. We'll label our coefficients A, B, and C. And then we're going to do the same thing, multiply A times C so that we can look at the factors of, well, this will be 1 because there's an understood 1 in front of the x to the 4th times -36. So we're looking at the factors of -36 that will add or subtract to give us -5. So 1 and 36, 2 and 18, 3 and something. Is it 3 and 13? No, that would be 39. So 4 and 9, 6 and 6. So to me, 4 and 9 look pretty promising, provided that we make this a -9, because -9 plus 4 will give us the -5 that we need right here. And also -9 times +4 will give you the -36, which we got right here. Is everybody okay with that? Okay. Now, I sort of caution this. Anytime you use the AC method, there are certain problems where like two combinations of factors will look like they'll give you this middle term. So you just have to be very careful with this sign right here. Because if I have a negative number here, then only one of these numbers can be negative. Because when I multiply a negative times a positive, I'll get that negative. But if this was a positive, then both signs need to be the same, either both positive or both negative. So always make sure that both of these conditions are satisfied before you rush into the next step. Okay. So we'll take this middle term the same way we did with quadratics. We're going to split that up. But this time, the middle term is x squared. So when we split this up into, we could split this up however we want. I like to put the negative number first. So -9. This will be -9x squared plus 4x squared. Since the middle term is squared, both of these two terms need to be squared so that when you combine them, they will make the negative 5x squared. Okay. So don't just mindlessly put x, right? They need to, I sort of think of it like if this is the parent and the parent is an x squared, well, then both of the children need to be x squared as well. So then we'll bring down our middle terms or the terms on each end like so. And I'm sort of ignoring the equals 0 for now. And we're going to factor by grouping. So the first two terms have an x squared in common. So I'll factor out x squared, which leaves me with x squared minus 9. The next two terms have a 4 in common. So now we should have x squared minus 9 here as well. Is everybody okay with that, or are there any questions? Okay, well, the final step of factorization would just be to take our common factor, which is this polynomial, and notice that the polynomial is a quadratic because we have x squared. We'll take that quadratic polynomial and bring it to the front. This is technically a positive 4. So x squared plus 4 will be our other factor. And that is still equal to 0. So the second step is going to be use the 0 factor property, which in simple terms would just mean take these factors and set them equal to 0. So in this particular problem, we have x squared minus 9 is equal to 0, or x squared plus 4 is equal to 0. So we have two equations to solve, but they are not linear equations. X squared minus 9 is a quadratic. X squared plus 4 is a quadratic equation. So now we have to solve these quadratic equations using one of the three strategies that we have left over, right, for solving quadratics. And in this particular case, I would say we have to solve the quadratics, and the easiest way to do it is using the square root property. So I'm going to resume on the next page once you guys write this down. So these are the two equations that I need to solve. Need to solve. Okay. So I have x squared minus 9 is equal to 0. And really, you could use any three of the strategies for solving quadratics here. If you knew how to factor this, you could factor it and then use the 0 factor property again, set those linear factors equal to 0, and then get your solutions. But I think that this is going to be way easier to use the square root property rather, because if we move the 9 over to the other side by adding 9 on both sides, right? I guess I get a little bit lazy. Like once you get really familiar with moving things around the equation, I always say like just move this over. But what's implied is that, right, you're adding that. You're using the addition principle. So we get x squared is equal to positive 9. Well, we want to get x by itself. So the square root property is going to be super convenient here, because the square root property just says take your equation and take the square root of both sides. So if we take the square root of that side and that side, we get x is equal to plus or minus 3. So just keep in mind here, this is two solutions. We have a positive 3 and we have a negative 3. But we need a total of 4 solutions. So you can't forget to take the other factor, which was x squared plus 4 equals 0. And then solve that, again, using the square root property. So I would subtract the 4 on both sides here. So you would have x squared is equal to negative 4. And then I would use the square root property on this. Let me write it out again. Take the square root of both sides. So I get x is equal to plus or minus. Recognize that this is going to be an imaginary number because I'm taking the square root of a negative. So I'm just going to focus on the positive part, the positive square root. So the square root of positive 4 is 2. So this should be 2i when you simplify that radical. So here are 2 of your solutions. You have positive 2i and negative 2i. So your solution set is going to be, and it doesn't matter what order you put these in, negative 3, comma 3, comma 2i, comma negative 2i. Those are your 4 solutions. For these, you don't have to check. You don't have to check your solutions. As long as you got 4 solutions, you should be good, right? So are there any questions or comments about this problem? At the very beginning of the problem, it felt a lot like a quadratic equation. You factor, and then you get 2 factors that you set equal to 0. But because this is a quartic equation and these 2 factors at the end are quadratic, then you have to solve those 2 quadratic equations. Okay. So just make sure that you separate those 2 quadratic equations, you solve them correctly, and that at the end you should have 4 solutions. Okay. Well, now I'm going to give you an example so that you guys can work on your own. So we want to solve the quartic equation, which is 8x to the 4th plus 2x squared is equal to 15. So I'll give you guys about 10 or so minutes to solve this one. And remember, the steps are to factor using the AC method, then once you factor, you're going to use the 0 factor property, and then you're going to solve your quadratic equations. And then I guess maybe the fourth step is to make sure you have 4 solutions. Although I really enjoy doing this, having a step 0. You need to put this in standard form before you begin, okay? Don't just rush into it, just barreling through it. Make sure that it's in standard form or that the equation is set equal to 0 before you begin. Okay. Let's jump back in. Was anybody able to complete the this problem?
I did. I don't know if it's right or not.
Yeah, that's going to be like the perennial response, right? Yeah, let's, as long as we've gotten to something that feels like an ending, I think that's a good place to be. If we made mistakes, we'll just have to go back through it and figure out where those mistakes were. But I'm going to go ahead and jump in. If you're still working on this, go ahead and continue working on it on your own. And don't mind me. I'm just going to be narrating this problem as I work through it, like usual. So at the very beginning of this, I said step 0 would be to put this in standard form. So we need to move this 15 over, subtract it over to the other side before we can even begin factoring, because we need it in standard form. Otherwise, we wouldn't have a trinomial, or rather, this number here, if we labeled it A, B, and C, this would be the wrong sign. Okay. And right away, I can tell that 8 times 15 is going to be a really big number. Okay. So these are the main steps, but I'm going to throw some scratch work over here. I know I need to do the AC method, so I'm multiplying A times C, which in this case will be 8 times negative 15. That will turn out to be 4 times 15 is 60. So this should be 120, negative 120. Always got to double check that mental math in the calculator. Negative 120 is good. So negative 120. We got to look at the factors of negative 120. And since this middle number is sort of small, what you might do is try to guess some factors that are close to getting us near 2, or a small number. Like when you add and subtract them, those numbers are going to be close to each other, so that whatever's remaining is just going to be a smaller number like 2. So I might say, okay, if you started at 1 and 120, that's perfectly fine. You can list all of the factors. You're just going to have a longer list because this is a bigger number. But if you wanted to, you could just jump up and say, okay, this would be 6 and 20, right? Because that would be 12. 6 times 2 is 12, so 6 times 20 has to be 120. But then those don't add or subtract to give us 2. So we need to go a little bit bigger. Maybe we'll go to 12 and 10. Okay. So again, I didn't go through the entire list. I just said those numbers have to be sort of close to each other so that when I add or subtract them, they'll give me a relatively small number. But again, like I said, you could go through the entire list. You just have to quickly whip through that. 12 and 10 work. And I need one of them to be negative. So I'm going to make the smaller one negative so that when I add them together, I will get a positive 2. So those two conditions are that positive 12 times negative 10 does give you the negative 120, and also 12 plus negative 10 gives you the positive 2. So we can go ahead and break this middle term up. Remember, the middle term gets broken up into, let's go ahead and call it, it doesn't matter what order you put this in, 12x squared minus 10x squared. Usually I like the positive number first, but if you're just whipping through this, this is fine. You're going to end up in the same place. That's positive. We're going to factor by grouping. These two terms have, what do they have in common? Their greatest common factor is a 4. 4x squared. So that means that I would need a 2x squared there, so to get the 8x to the 4th back. And then I would need a positive 3 there. On the other side, both are negative, so I'm going to factor out a negative. 10 and 15 have a 5 in common. So negative 5 times positive 2x squared will get me back that negative 10x squared. And then this next thing should be the positive 3 here. And you can just double check that negative 5 and positive 3 does give you the negative 15. So now that these two match, in some combination, you should have these two factors, 2x squared plus 3 and 4x squared minus 5. And those two factors are now equal to 0 because of the zero factor property. It doesn't matter what order you solve these two factors in when you set them equal to 0. I'm just going to take the first one I have here, 2x squared plus 3, set that equal to 0. And then I'll use the square root property again. So maybe I'll subtract the 3 over to the other side to give a negative 3 there. And I'll have 2x squared here. I'll isolate the x squared here, but by dividing the 2 over, so I have x squared is equal to negative 3 over 2. And then now I can properly use the square root property, take the square root of both sides. So I should have x is equal to plus or minus. This is the square root of a negative number, so I should have an I. And just for simplicity's sake, I'm just going to leave it as the square root of 3 over 2 since that does not simplify. And you guys can't see my solution, so there we go. Those are two of my solutions. Does anybody have any questions about this quadratic that I just solved?
So the only way I would take the 3 over the 2 out of the square root is if if there was a square root of that.
Yeah, exactly.
Like if it was a 9, then
Yeah.
it would be 9i.
Yeah, exactly.
Okay,
Well,
I got,
if there was a 9 inside the square
it
root,
would be 3i.
yeah, exactly. You got it.
Okay. Because I got that answer, but I just put it as 3 over 2i.
Okay, yeah. The I is just when you pull the negative sign out of the square root. But you would still have the square root of 3 over 2. And since that doesn't simplify, you're going to leave it as a radical. Yeah.
Makes sense.
Good question. Any other questions on that particular part? Okay, so then we have to solve the other quadratic equation. So we're going to set this factor equal to 0. And you'll notice that when we add the 5 over here, we're going to get a positive 5. And so I want to contrast this just quickly with the other equation that we solved. When you move a number over and you get a negative here, once you take the square root of that negative number, you're going to have the imaginary number on this set of problems, or this set of solutions. But because we moved this over, the negative 5 over, and it became positive, eventually when we take the square root of both sides, we're going to have the square root of a positive. So this will be a real number, not an imaginary number. But the process pretty much goes the same. We're going to divide the 4 over to the other side, so you get 5/4. We're going to write the problem one more time because we need to take the square root of both sides, like so. And then we get x is equal to plus or minus. Again, there's no need for an I here because we don't have the square root of a negative number. But while we can't take the square root of 5, you can take the square root of 4. So you could write this as the square root of 5 over the square root of 4, which would be plus or minus. The square root of 5 does not simplify, but the square root of 4 is just 2. So you have two solutions here. You have two solutions here. So your complete solution set would be, and again, it doesn't matter what order you put this in, I square root of 3 over 2, comma, negative I square root of 3 over 2, comma, square root of 5 all over 2, and negative square root of 5 all over 2. So be very careful when you type this into MyLabs Plus, because for this, these sets of solutions, both the 3 and the 2 are inside the square root, right? The only reason why this 2 is outside of the square root is because we could take the square root of 4. So that would be your 4 solutions. Any questions? Solution set. Okay. So let us see. Today's Wednesday, which is the last time that we meet this week. Let's do this. Next week, we'll finish up 1.6, section 1.6, and we'll look at the other types of equations, which would have been the 5th and 6th types of equations, which are the radical equations and equations with rational exponents. And we'll sort of see that these are really two sides of the same coin. They're interchangeable. But I don't want to get us bogged down, and obviously we don't have nearly enough time to finish two more types of equations. So we're going to finish this section. And then I think that what I want to do, we're going to finish this on Monday. Then on Wednesday, I think it'll be really important for us to have a review day. So we'll meet on that Wednesday, and we're going to go through solving as review all of these other types of equations that we're being exposed to now. And then we're going to be taking test 3. So I'm going to be creating that over the weekend, but I won't open that up. I'll open that up after class on Wednesday. Next Wednesday. Okay. And then it'll be open for a week like normal. And then we'll get into some new material after that. Let me go ahead and zoom out because you can't see all of this. All right, there we go. Okay, so I know you guys were like in for a roller coaster ride today. I was dragging you through this begrudgingly. And that's just going to have to be how it goes until we start, getting more of that practice in. So make sure that, before we come to class, you should probably whip through a couple of problems from the previous class just so that you have the state of mind prepared to take on the new stuff, right? Because you don't want to be like, oh, what did we do last time? And then be dragged along. It's going to be like a lot worse. So make sure that you're, as always, reaching out to me if you need the help. Send me messages, send me screenshots of problems that are giving you issues. Come to Math World, send me a message so that we can work on stuff during office hours, because it does not slow down, right? Everything is building up to this. I would say that arguably test 3 is the most complicated thing because you have to be able to solve these 4 different kinds of equations. After that, it does get a little bit strange because we're going to be heavy into graphing after test 3. So we have to have these algebraic principles down so that the graphing makes sense, because the graphing requires a lot of the algebra to work up to it. Okay. So again, long story short, just make sure that you're reaching out to me. I'm here to support you. I'm going to be working on grading test 2 now that they're going to be all complete or turned in. For the most part, you guys have turned those in. If you did not get the grade that you wanted to, just give me a couple days to work through the work that you've turned in so we can see what kind of partial credit is going to be due back to you. And then once you get that feedback, then go ahead and start asking me like, okay, what does my grade look like in this class, right? Because then I'll have a better idea once your grades are updated where we're sitting, okay? Or where each of you guys is individually sitting in the class. But I need to get test 2 graded and updated in Canvas. Otherwise, I don't really know. Okay, so just be patient. Look for those in the next couple of days, those updated grades, and just reach out to me. Just communicate with me when you need to. Okay, you can text me through Remind at any time of day. If I'm feeling generous and I'm up at 12 or midnight or 1 o'clock in the morning, I will respond. I've been known to do it. Okay, so just make sure you're reaching out when you need that help. If you don't have any questions, or if you do have any questions, feel free to hang back. But otherwise, you're free to go and enjoy the rest of your day.
Thank you.
Thank you.